Hello, I wanted to talk a little bit about the unit circle and trig functions. I know a lot of students tell me they want to memorize it again, and I encourage you if that's what you want to do and you're good at memorizing things. I want to show you another way that you might think about it so that maybe you don't have to memorize it, you just intuitively understand it a little bit better. So I have a picture here right below of the unit circle. You're familiar with it. In calculus, we basically use radians, so I'm going to talk mostly about radians. So we're looking at things like my 0, pi over 6, pi over 4, pi over 3, pi over 2, and so on. Just a really quick side note to go all the way around the circle once, I'm also at 2 pi. Okay? So let's take a look at those angles real quick. If I take a look at the angles, let me change colors here real quick. If I look at the very first angle, well, let's start before that. Here I have 0, again, here I have pi, and over here I have 2 pi if I've gone all the way around the circle once. That means that right up here, let me make this a little smaller so you can see it all, is pi over 2. That's that 90-degree angle straight up, and down here is 3 pi over 2, okay? So the angles, if we concentrate on the first quadrant here, this first one is pi over 6, all right? That means I've cut the top half of the circle, just that top half, into 6 bits. The next one of interest that we call a standard angle is, that's a nice straight line, is my pi over 4. Pi over 4 is about 45 degrees. It means I've cut the top half of the circle into 4 pieces. If I look at the next one, my next common angle up there is going to be a pi over 3. That means I've cut the top half into 3 pieces, and you can see that if I look at this whole right angle here, pi over 2, that's my 90-degree angle. I've cut the top in half. So what I want you to notice here, just so that it clicks in your brain, is that the denominator decreases as the angle gets larger, okay? So you can kind of see that. If I look at something over in, let's say, the second quadrant, I can cut that top part into all 3 pieces. Here, let's change colors real quick. This right here is going to be 2 pi over 3, all right? And then we'll count up, all right? So this is also 3 pi over 3, if I wanted to count by the thirds. All right. So one really quick note, pi radians is 180 degrees. Hopefully you learned that in your trig class. If not, it's important to know. And notice that we really deal in the radians. Radians is just a different form of measurement, just like inches versus centimeters or something like that. Let's go ahead and talk about those angles there in quadrant 1. So we know we have 4 quadrants. We have Q1, Q2, Q3, and Q4. Oh, maybe. I'm going to concentrate on the first one. Like I said, this is 0. This up here is pi over 2. I'll label pi just so we have it. If I look at those angles that we had, I'm going to draw all 3 of them and then I'll label them for us. Remember, this first one's pi over 6. This one's pi over 4. This one right here is pi over 3. All right. Now, the unit circle is a circle with a radius of 1. So I know, since it has a radius of 1 right here at 0 radians, that the point, if I think about my Cartesian point, is 1, 0. Okay, I've done 1 in the x direction, 0 in the y direction, kind of makes sense. If I look at the point up here at pi over 2, I have a ordered pair up there. I'm actually going to move the order. Actually, I'm going to move the pi over 2. Move that over here. I have an ordered pair up here that's 0, 1, because I've gone 0 in the x direction, 1 in the y direction. Now, here's the cool thing. I'm going to rewrite these. I don't want you to write these like this on a test. So I could rewrite 1 as the square root of 4 over 2 and the square root of 0 over 2, right? Same thing. Up here, I could rewrite this as the square root of 0 over 2, square root of 4 over 2. All right. Please don't write it like that on the test. Reduce it and put it back into 1, 0, or 0, 1. But the cool thing is you can see a nice pattern. You notice that as I go from the 0 radians to pi over 6 to pi over 4 to pi over 3, and then finally to pi over 2, that the x value or the x distance that I've traveled decreases, right? I'm getting closer to that y-axis, so that the distance that I've moved over in the x direction, like this way, is less for this and less for this and less for here. So I'm going to count down. Watch what happens. I get a square root of 3 over 2 on my x distance for the first one, a square root of 2 over 2 on the second one, and a square root of 1 over 2. That's going to be a 1/2. I'm going to reduce these in a minute for the pi over 3. So what you can see here is that I go square root of 4 over 2, square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, square root of 0 over 2. I'm counting down in that first quadrant, all right? Let's take a look at the y's. The y's, instead of counting down, I'm going higher up. I started at a height of 0, a y value of 0. I'm going to go up, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and you can see up at the very top here I have a square root of 4 over 2. So my x's count down, my y's count up. I want to make sure that you're using the reduced forms here. So this one's going to be a 1/2 square root of 3 over 2. This is what you commonly see on your unit circle, square root of 3 over 2 and a 1/2 here. So the ones I want to see on, let's say, an exam, if you give me an answer, are the ones I'm highlighting here. I just showed you the other ones so that you can start to see that pattern of how we count down, all right? So this is pretty cool. It's a nice way to remember them. If I go to, let's say, the other side real quick, let's go to quadrant 2 over here. Let's do this 45, which is going to be, this is going to be right here, a 3 pi over 4. When we talk about reference angles, we're looking at that angle between the x-axis and my angle. So this is pi over 4 is left, right? So if I look at that, I'm basically symmetric to this one. The numbers for my displacements are going to be the same. It's just the signs are going to change. Here, my x displacement, if I think about where I'm going in the x direction, I'm negative square root of 2 over 2, but I'm still positive in my y direction, so square root of 2 over 2. All right. So you can kind of look at where you are on that unit circle and figure out what your values are and whether they're positive or negative, and you don't just have to memorize it all. All right. Now, let's take a look at the beauty of the unit circle and how we use it to find trig functions, all right? So I'm going to page down to this one. Here I have my pi over 6 angle. We just said that that has coordinates square root of 3 over 2 and 1/2. I had written a square root of 1 over 2, okay? Unit circle, again, it has a radius of 1. We know that because right down here I'm at 1, 0. And right up here, I'm at 0, 1, okay? So I'm gonna make this a little bit tinier. All right, so what we're gonna look at is, let's turn this into a triangle. So I'm gonna drop a line down here. If I turn this into a triangle, and I look at this distance right here, it's my x displacement to get to the point that I have right here. So what I can say is that this distance is square root of 3 over 2. I also know that I went up in the y direction. My height of my triangle is going to be 1/2 because that's what my coordinate right here tells me, okay? Unit circle, so my radius is always 1. That means my hypotenuse is 1 when I draw these triangles. It's always 1, which is the beauty of how this all works, all right? Now I'm going to use SOHCAHTOA real quick. So let's take a look at that triangle. If I use SOHCAHTOA, I know that sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. So let's say I want to find sine of pi over 6. All right, then I know that's equal to my opposite over my hypotenuse, which is equal to 1/2. That's my opposite angle over my hypotenuse, which is a 1. over 1. Anything divided by 1 is going to be itself, so I'm just going to have 1/2. If I look at my cosine of pi over 6, I'm going to have my adjacent over hypotenuse. I'm shorthanding it now. My adjacent angle, or side, sorry, is this, my square root of 3 over 2. So I have square root of 3 over 2, again over 1, which is going to be equal to root 3 over 2. Okay. If I look at tangent, I can either use my previous two values, or I can say tangent pi over 6 is equal to opposite over adjacent, which is going to be my opposite was that 1/2. My adjacent is root 3 over 2. If you want to do keep, change, flip, go for it. I tend to multiply top and bottom by the same number, so I multiplied by a 1. That means I can cross out this 2 with this 2, this 2 with this 2, and what I come away with is that tangent of pi over 6 is 1 over root 3. If you want to rationalize it, you multiply both numerator and denominator by the same thing, that root 3, to get that square root out of the denominator, and I end up with root 3 over 3, which is what you're going to see in most of the tables. Pearson wants the root 3 over 3. Personal opinion, if you stop here on my test, I really don't care. Perfectly fine. All right, so let's look at the angle pi over 6 real quick. All right, if I look at the angle pi over 6, and I thought I was going to do, wait, let me look. Oh yeah, okay. If I look at this angle pi over 6, let's look at a couple of the things there. I want you to go ahead and try, put in your ordered pair up here. All right, draw your triangle, and let's see what things are. Go ahead and pause the video now, and then I'll pick up when you come back. All right, so the point up here, remember, is going to be 1/2 square root of 3 over 2. That means if I look at my triangle, I'm going to have a side here that's 1/2 and a side over here that's root 3 over 2. All right, that means that if I look at sine, well, let's write it as sine pi over 3. Pi over 3, that's going to be equal to sine by SOHCAHTOA is opposite over hypotenuse. Again, remember your hypotenuse is always 1. So my opposite's root 3 over 2 over 1, which is root 3 over 2. If I look at cosine of pi over 3, that's adjacent over hypotenuse. So I'm going to get a 1/2 over 1, which is just a 1/2. If I pop over here and I look at tangent of pi over 3, that's going to be opposite over adjacent. So that's going to be, my opposite is root 3 over 2. My adjacent is 1/2. Again, multiply top and bottom by my 2's. If you'd rather do keep, change, flip, or some other thing, go for it. All right, I'm going to cross out my 2's, and what I'm going to come away with there is that this one is equal to just root 3 over 1, which is root 3. Right. So not bad at all. There's another video coming that kind of shows how you move this into other quadrants, and you can use it in other quadrants. This gets you through the first one, and then you can use reference angles to find your values in other quadrants. If you have any questions, let me know. I hope you found this helpful. Thanks. Bye.